When I started using computers, there were only about a dozen computers in all of New York City. Now we all carry multiple computers in our pockets and our belts, but computation is a lot more pervasive than these gadgets we carry around. Take this rock, for example. Doesn't look like it's doing very much, but it has trillions of atoms and molecules in here. They're all moving around, bouncing against each other at incredibly high speeds. That's computation. That's not very useful today. It's organized kind of randomly. We can't communicate with it very well. But we're going to change that. We're going to reorganize the vast amount of computation in this rock to make it useful. And it won't just be raw computation. We'll infuse it with exquisitely intelligent software, vastly greater than our intelligence today, and with all the knowledge of the human-machine civilization. This rock is going to be a trillion times more powerful than all biological human brains today. This is going to be quite a valuable rock. We call matter and energy reorganized in this way computronium. We're going to reach these limits late in this century, and at that time, we're going to turn many of the rocks and other stuff suitable for computation into computronium. And so, to keep the expansion of our intelligence going, we will then need to spread out to the rest of the universe, turning some portion of it into computronium. How fast can we do this? That depends on whether or not we can transcend or otherwise get around the speed of light as a limit. There are suggestions that there may be subtle ways of doing this. One possibility is to send intelligent nanobots through wormholes, which are basically shortcuts to apparently faraway places through other spatial dimensions beyond the three we're familiar with. Wormholes through space appear to be consistent with our understanding of physics. If it is indeed feasible to either find or build such wormholes, our intelligence will be so great that we'll be capable of engineering these shortcuts to reach other parts of the universe in brief periods of time. In that case, we could infuse the universe with our intelligence rather quickly. It would require only another century, that is by the end of the 22nd century, to saturate the universe with computronium. On the other hand, if we can't get around the speed of light, it'll take a lot longer. But in either case, expanding our intelligence throughout the universe is our ultimate destiny. Cosmologists today argue about whether the universe will die in fire or ice. Fire means a big hot crunch, basically the opposite of the Big Bang. Ice means stars flying apart, eventually dying out. Both of these views of cosmology assume that intelligence has nothing to do with it, that intelligence is just a bit of entertaining froth that dances in and out of the dumb celestial forces that rule the universe. But this perspective ignores the law of accelerating returns. As a result of the exponential expansion of our knowledge and skill, the universe will ultimately be infused with computronium and with the vast intelligence of our human-machine civilization. So the universe will wake up, and we will intelligently decide its fate.